My name is Jang Ho-pei. I'm working for the SoC marketing group, the Samsung.
So, what are you showing here? Exynos with advanced technology? What do you mean?
Advanced technology means the wide I/O technology. The wide I/O memory, wide I/O technology is kind of a memory interface technology. It's like the LP-DDR3. Actually, this demo shows the difference between the conventional LP-DDR3 memory interface and then the new technology, the wide I/O memory interface technology. To run the same application, to run the same workload, we can see the power benefit of the wide I/O memory interface. We can have the 60 to 70 power saving.
Yeah,
from the
60 to 70% of the SoC?
No, the memory power plus the memory interface power inside of the application processor.
So it's only the memory power consumption.
Memory plus memory interface within the application processor. Actually, the IP is related with the memory, which is a larger part of the power consumption inside of the application processor.
What is this? And this?
This is the power consumption of the AP plus memory, and then this one is LP. The same one, but the right is using the LP-DDR and the left side using the wide I/O.
So, is this on the market?
Not yet.
Not yet?
What we want to say here is to show our readiness for this technology.
So it's ready?
Yeah, it's ready for the market, but the business is about the timing. So we are searching for the best timing for this technology.
It looks cool.
Yeah, it's really cool.
Does it make for faster memory or?
Of course, the major three benefits are there for the wide I/O. The first one is the power saving, but the second one is the wider bandwidth. Actually, for this one, the LP-DDR3 current version has based on the two-channel solution that has been used for premium smartphones. It has the 12.8 gigabyte per second right now, but this wider technology has a 17 gigabytes per second.
17?
Yeah, 17, which is 30% higher than current versions.
That's awesome.
Really awesome. And also, the increasing the memory bandwidth through the wider technology will be easier than LP-DDR3.
So that means 17 is just the beginning?
Yeah.
It will go up?
The initial starting is the 17 gigabyte per second.
It'll go up to how much?
Go up to. It's hard to say. But
more than 100?
Yeah, up to 100 in some time, maybe.
Really?
I don't know exactly, but
How does it work to increase memory bandwidth? How does it work?
To increase the memory bandwidth, there are two ways. The first one is increasing the operating frequency. The second is increasing the number of data lines. Actually, the history of the LP-DDR is more focus on increasing the operating frequency. So the current LP-DDR3 runs at 800 megahertz. But the first version of the wide I/O runs only at 266 megahertz. But the LP-DDR3 has the 64 data bits, but the first version of the wide I/O has 512 data bits. So only with the 266 megahertz, you can have the 17 gigabyte per second.
So if you do same megahertz, what happened?
The times 2 to 3 times higher bandwidth.
2 to 3 times is possible.
Yeah.
So that means the ARM processor of the future is going to have so much memory bandwidth, there's no problem to run a laptop, to run a full desktop computer.
Basically, I believe the demand for the memory bandwidth for the smartphone devices will surpass the demand for the PC memory bandwidth. I mean the conventional PC.
Because this laptop should be Exynos inside, and it should be
definitely sometime
Exynos inside with the super fast memory bandwidth. Is memory bandwidth more important than CPU speed?
Both should be accompanied to increase the overall performance.
Which one is more important?
Even though we have so much powerful CPU power, it will be useless if there is not enough memory bandwidth. Because the bottleneck happens in the memory bandwidth. The data should be written and read throughout the memory interface between the IPs, including CPU and memory. So if the bottleneck happens there, no useless for any powerful IPs, or CPU or GPU.
So when we talk about 17 gigabyte per second, how does that work? How can it be so much data per second? From where to where? What is this?
This shows the package structure.
What is this? What is that?
This is the LP-DDR and this is the application processor.
And it's talking to all over the place?
Yeah. The left side is the LP-DDR3, the POP structure, and the right side is the wide I/O memory interface. Actually, that's made by the TS3 technology.
So that means that before it was going through a cable, kind of, and now it's going directly?
Directly connected. From the memory to AP. Directly.
How many connections are there?
Now, the current version, we made over thousands of connections. Among them, we use the 512 data bits.
And what I'm trying to ask is, this DDR3, I've heard this before when I buy a computer.
When you buy a computer, what?
When I buy a computer, a PC, and I want to configure it, it's always DDR3, Does that mean wide I/O is something that's happening in the desktop, in the x86 world too? Or is this only for ARM?
Maybe the TSV technology that can be used to realize the wide I/O technology to be adapted to the application processor. But for PC side, maybe I think if it is possible, graphic memory, something like those kind of parts that needs a higher bandwidth will start to adapt the wider technology, I believe.
All right. So what do you do every day?
Every day?
What's your job?
I'm a marketing manager, so I'm doing I'm seeing the market, how the smartphone and tablet markets are going, how futures we will face in maybe next year or in 2 to 3 years. I'm imagining my future, and that's my job. That's my job.
Imagining the future.
That's my job. That's my duty. So making the application processor needs a lot of time. So we have to figure out what should be in the next year or in 3 years. That's from that job, we design the application processor and we fix the specification of the application processor. We start the design.
So what's going to happen in 3 years?
It's hard to say.
But you know.
I mean that, yeah.
The secret?
Not the secret, but please understand me. Here. This is I know that you're a very famous blogger in the world.
Really?
So I believe staying here means a lot of. It's like a broadcasting to the world. So.
Yeah, but can you explain how this is made? Who's working on this? And a lot of engineers. And how do they work on it? In the office or in a laboratory, in a lab, or?
Actually, to realize this kind of a solution, there should be tight collaboration between application processor and memory and package solutions team. So we have, the Samsung has a lot of smart engineers for the application processor, the memory and package. So we collaborate each other and make this solution.
Cool. Okay, so how soon can I buy a phone with a wide I/O?
And the market needs it.
Maybe next year? Maybe later. Okay.
Yeah.